Today's topic is on fetal circulation. I hope you have the chance to go through on one of the notes that I just sent on my link. In this topic particularly, we are going to focus on fetal anatomy, the heart, the fetal heart anatomy. So I've just sketched the heart, and this is my left ventricle. So this is my left side of the heart. And since I'm standing like this, so this will be my right side. This is specifically the heart for the fetus while it's still in the uterus. Because what fetal circulation is, it is specifically the systemic circulation of blood before the fetus is outside of the uterus. So the heart of the normal human being, the adult human being, of a baby, someone who's outside the extrauterine life, is different from someone who is in the intrauterine life. So of course we still have the inferior vena cava. This is the inferior vena cava. And this one is the superior vena cava. It's draining the top half of the body. This one is draining the top half of the body, the lower part of the body, sorry. So this will be the superior vena cava. And then this one is the aorta. This one is both this and this, these are what we call the pulmonary veins. These are the ones which are taking blood to the lungs to be oxygenated. So this will be the lung. So this will be the left lung. And this one will be the right lung. But this is the left ventricle and the left atrium. So this is the left atrium, right ventricle, left atrium. Now, in fetal circulation, of course, it is different from the adult human being, in the sense that in the fetal circulation, when you go on the septal, the cardiac septum, you will find that in a fetal circulation, through that septum, you are going to find what we call the foramen ovale. This is the window, because foramen means window. So the foramen ovale, this is the window which is between the left atrium and the right atrium of the fetal heart, the fetal heart, of course. So this one will be the foramen ovale. And what this one does is that since blood cannot be oxygenated by the lungs, it cannot be taken to the lungs it will be taken to the lungs, of course, by the pulmonary arteries, but it will not be oxygenated. So oxygenated blood is going to come from the placenta of the mother, and then it's going to go through to the right atrium, and then it will go directly into the left atrium through the foramen ovale, which is the window, and then from there it will go in the left ventricle, and then it will be circulated throughout the body. Since we are talking about the fetal circulation, we are going to draw. It is very important for us to understand the anatomy of where the blood, the oxygenated blood, is coming from. Where does this fetus get its blood from? The oxygenated one. And where does it take its deoxygenated blood to be deoxygenated, since the lungs are not working? And the reason why the lungs are not working is because in the fetal artery, in the fetal heart, the lungs, in the fetal circulation, the lungs are completely filled with fluids, the air sacs. The air sacs are completely filled with a lot of fluids before the extrauterine life of the baby. So blood is going to come from here. So this one will be the. So we are going to draw the liver. So this is the liver. And the liver gets its blood supply from the placenta via the umbilical vein. So we are going to draw the umbilical vein and the placenta for us to understand where this is coming from. So this is the placenta. Of course, the placenta is very important because it supplies the fetus with a lot of nutrients that it needs in order for it to grow. It's going to supply the fetus with vitamins, oxygenated blood, which is of course important again for the process of this energy formation, metabolic processes, because it's going to take place once there is oxygen. So the placenta is very important. And also the placenta is also going to supply the baby, the fetus, with a lot of immunoglobulins that the mother might, also even the antibodies that the mother might have come across during her lifetime. So for example, if the mother developed the antibody for herpes virus or the simple herpes virus, the antibodies that were manufactured by the mother during that process, when she developed that virus, they are also going to diffuse in through the placental membrane and then into the fetal blood, and then the fetus will benefit during that time once it's still in the uterus. So the placenta is very, very important. And one thing to notice is that the placental, the mother's blood and the fetal blood does not mix. They don't come in contact once they are in the placenta. And this is made so possible because of the placental membrane. There is the physical gap. It's such that the blood vessels of the mother are passing on the other side, and then the blood vessels of the fetus are passing on the other side. And then in between, there is what we call the placental membrane. It is only through that medium that the mother's oxygen is going to diffuse in through to go in the blood of the fetus, and also the carbon dioxide from the fetal blood is going to diffuse from its blood into the mother's blood to be excreted by the body or the mother. So it's very important to notice that the placenta, in the placenta, the mother's blood and the fetal blood does not mix. So this is the umbilical cord. And of course, the umbilical cord is made up of the 3 blood vessels. There's going to be the umbilical vein, which is going to take blood with oxygenated blood towards the liver. So we are going to get the umbilical vein. We'll start with the umbilical vein first, coming from here. And the umbilical vein carries oxygenated blood along with all the necessary nutrients that are needed for the fetus. And it's going to carry that oxygenated blood from the placenta towards the liver of the fetus, and inside before it reaches the liver exactly inside, there is a wall in the arteries where the inferior vena cava bifurcates with that artery joining the liver, and that wall is called the ductus venosus. So, the liver, of course, it's here, and then it's going to bifurcate, and then it's going to take some of its blood to the liver, to other parts of the body, and then the oxygenated blood is going to go direct to meet with the inferior vena cava, and this way, this is what we call the ductus venosus. And at this point, the oxygenated blood is going to come in contact with the partly deoxygenated blood from the lower parts of the body. Simply, the percentage of the oxygen is going to reduce, which is in the blood, because at this point the blood has come in contact with the blood which is coming from the lower limbs, and that blood is partly deoxygenated. So it's going to be taken to the upper part of the heart still. The blood will go, and then it will go in the right side of the body. Also, the blood from the superior vena cava will also come, and then will meet. Instead of blood going through the right ventricle and then being pumped to the pulmonary arteries, the blood is going to go directly, since it's already oxygenated from the mother. So it's going to go directly into the left atrium, because it is from the left atrium where we are going to get the blood into the left ventricle, and then it will be pumped in the blood by the aorta, because the aorta is the only body pump which is going to pump blood. We term this as the left side of the body is the body pump. So the body pump is this side. This is only the lung pump. It's going to pump blood to the lungs to be oxygenated. But in this case, in fetal life, the lungs are completely filled with fluid, so they are not working anymore until after birth. So blood is going to come, and then blood is going to go through the foramen ovale. That is oxygenated blood. And then once it goes through the foramen ovale, it's going to go down. So blood comes from the right atrium directly in through the foramen ovale. But as it's going this side, some of it will also go in this side, the left ventricle, the right ventricle. Some of it will go here, and then it will be pumped to the pulmonary arteries and into both lungs. But there it will be resisted. There will be pressure. So once blood is resisted here, it's going to go through here by force, of course, and then it's going to go to the lungs. It will be pumped. Since there is resistance in the lungs, blood will not come back through the pulmonary veins, because there are 4 pulmonary veins in our body. The right 2 pulmonary veins carrying blood from the lungs towards the heart, and then the left 2 pulmonary veins. But in this case, since there is resistance in the lungs, because the lungs are completely filled with fluids, so there's going to be that resistance in the lungs. Hence, blood will come back again via the pulmonary arteries, creating pressure. And once blood comes back through the pulmonary arteries, that is the backlog of blood, we are going to have pressure in here. Also, blood is not going to go in the lungs and come through this side so that it goes in the left side to be pumped in the right side of the body. It will go back to the right ventricle, and then it will start coming back downwards. But this, the already oxygenated blood has gone through this side. It will go in this side, and then it will go in the left ventricle. And then that's when it will go in the aorta. the aortic valve. From the aortic valve, the blood will then be pumped. The other one will go this side, the other one will go this side, the other one will go this side to be distributed to the top half of the body, and then the other one will go on down here. But because of that pressure, God had a purpose, and he knew that this would bring a lot of complications in the baby. The pressure which is coming from the lungs. He created this. This is what we call the Ductus Arteriosus. And the Ductus Arteriosus is very important in that it prevents the damage to the heart as a result of the pressure which is coming from the pulmonary arteries, which is supplying the lungs, of course, with blood. Since in the lungs there is resistance, that blood will come back via the pulmonary arteries, and then there will be pressure. But that pressure is reduced by the Ductus Arteriosus, in that it is open, and then it's going to take some of its blood in the aorta, in the arch of the aorta, thereby reducing pressure in the pulmonary arteries. And this is actually how blood flows through the fetal life. And the last thing I want to mention is where the aorta will bifurcate into two main arteries. There is going to be the iliac arteries, and from there, two iliac arteries, we are going to get two umbilical arteries. So these are two umbilical arteries, and these are going to take blood, deoxygenated blood, to the placenta via the umbilical cord. So there is going to be another one. So too many umbilical arteries are going to get deoxygenated blood to the placenta to be oxygenated again, and then come back at the same circulation. I hope you have enjoyed this lecture. The next thing that we want to do now is that we want to talk about what happens after birth once the umbilical cord is cut, because it is only when the umbilical cord is cut during birth that the baby experiences some of difficulties to adapt to the new situations, because everything was done for it, everything was given unto it, but this time now the umbilical cord is no more. So it means the baby has to start adapting to the new changes of life, and that is extrauterine life. That is what we are going to talk about in the next lesson.